No one person ever does a project like this by themselves. And I have with me the yellow team. Yellow team, where are you? There we are. A couple gentlemen on our yellow team chose to put jackets over their shirts. I won't be naming names, but they will be coming to the podium. Included in our group is a concept in which we work with a peer review group. And that has been an absolutely essential part of our both having advocacy and expertise that is well outside the framework of the Alliance for Sustainable Colorado. Included in our audience today are several people that I want to acknowledge in terms of their special role here. And that would be Joy Spatz, who is the architect. Thank you. It includes David Gary from Power Analytics. Thank you. Paul Savage from Nextech and eMerge. Andy Boyan from Dovetails. Thank you, who helped us with this messaging. And if it's not good, it's all our fault, not his. And Janice Six, who along with John Powers have put the mission of the Alliance Center behind this project. Thank you all. Now, I am no engineer. I do have several credentials that I can put behind my name, but the one that really comes to mind that is appropriate here is an MSH that Joy Spatz has laid on me, and that is Sandy makes shit happen. And so that's my role in this project. So I am pleased now to turn to my panelists who are going to give you the details, which is absolutely essential to your understanding, because in this case, the devil is really in the details. And for the first of these panelists, I am happy to tell you, is our chief integrator, Bern Gallagher. Bern?
Thank you, Sandy. I need this a little higher. Sorry about the light off the bald head there. It must be blinding you all. So my company, PVI, is right now building phase 1 of the Alliance Center's DC project. Phase 1 includes putting solar panels up on the roof, a DC distribution system throughout the building, and batteries in the basement for energy storage. So why DC? I mean, as Sandy said, Edison, he lost the war, right? With Tesla. I mean, George Westinghouse, he built an incredible utility system, right? AC transforms over long distances. It's been the IT power since the 1800s. It's just not that efficient in this century, the 21st, the one we're in now. So DC lost the war? Well, maybe not. I mean, renewable power is native DC. Wind can output DC. Batteries in your handheld devices, as Sandy said, they're DC, right? So why? Why DC? Well, it's finger safe, so you can touch it, use it. You don't want to get shocked by your cell phone when you hold up to your head, or remote control when you go to change the channel on your TV. Anything with a battery, anything powered by a USB port, anything electronic using an AC adapter. Your television set is DC inside. It just has a power supply inside of it to convert the power. In fact, we go at great lengths not to let AC get to our devices with surges and all. Surging AC currents destroys them. So why not AC? It's right there. Nikola Tesla was brilliant. It's much more complex to build that than it is DC. I went to engineering school. I mean, it was much tougher when we got to AC than it was dealing with DC, that's for sure. AC, though, has to go over a very, very long journey, okay? It starts off, let's take Colorado. A coal plant is the way that you generate power in Colorado, in general. You burn coal to boil water, to create steam, to turn an engine. all have losses in the process. Then you transform the voltage up, higher, and then higher again so you can transform it over long distance, 138,000 volts. Each process has losses. And then you transform it back down from 135,000 down to 35, down to 13.2, and then to 122.08 at your home or your office. And it's still not finger safe. I mean, don't put your fingers in the outlets. I mean, don't use it that way. Each transformation, each long distance uses power. You have losses along the way. 70% of the power during the journey to get from the power plant to that outlet is lost. And here in Colorado, at that Pueblo plant, I mean, this is environmentally conscious Colorado. You burn 1.4 million pounds of coal per hour, enough to fill 9 Denver Broncos stadiums. That's a lot of greenhouse gases. I mean, coal is carbon, and carbon is the enemy. If you want to see it yourself, you can watch the rail cars go from Wyoming and South Dakota right down through downtown Denver on their journey to Pueblo to burn that coal. So we're building a microgrid. Ultimately, our project goal is, like many of yours, is to reduce greenhouse gases. We do this by building the most efficient microgrid. And we chose DC because we want to reduce the conversions, reduce the transformations that cause losses, reduce the use of adapters, which are still not efficient themselves. Later this year, when this project phase 1 is complete, you'll be able to plug your devices, your tablet, into a USB port and charge it. No conversions. DC lighting? Well, that seems appropriate. I mean, Edison was the king of DC, right? We will have that also. We'll have LED lighting that plugs directly in without this socket conversion that uses up power here. And when you buy these in the future, they'll be easier to make and simpler, which means they'll cost less. But how about larger equipment? Like pumps and motors. I mean, 8 years ago, I bought a central air system for my house, 4-ton unit. It was a Tesla AC motor. It ran at 1 speed and cooled the house. And then I had to replace it. I replaced it with a VFD motor, a variable frequency drive, which is actually native DC. It can run at any speed from 20 to 100%. And if you know anything about motor consumption, at 50% load, they only take 25% of the power. So whenever you're running at lower speeds, you're saving energy. The elevator you're running today, they've always been DC because DC's been the choice of precision equipment. The escalator has a traction motor in it. DC's always been the source of powerful motors too. So how about larger commercial applications? Well, in varying roles, before I joined up with the Alliance Center, I designed or built reliable power systems, very reliable, for the 7x24 industry. People who lost money if the power went down. So, Primestar, I worked with DirecTV, QVC, I worked with Comcast, just helping with that. Or with Comcast, I worked with Verizon and Time Warner. And their main theme was risk management. They wanted to make sure that their power never went off. They had procedures to make sure you didn't accidentally turn the power off. And I'm personally aware of over 10,000 sites that these companies have here in the United States that are filled with equipment that are all native DC. They have distribution systems, DC distribution systems, to power those. Sure, there's some that run on AC, and they invert it from DC back to AC, and then the power supply converts it back to DC. Again, it's inefficient. When we lose power anywhere, we're burning more carbon. So why? I mean, these DC servers support your favorite TV show. I mean, you need your favorite TV shows. It's important to us. And they back up those servers with an enormous battery system, which we all know batteries are DC. These 10,000 sites, most of them are unmanned. Okay? They have to be able to run when utility goes down, when the backup generator doesn't function. They have to run for hours so they have time to get to the site. 5 hours, 10 hours of backup battery time. That's a lot. It's a lot of backup battery power. They used to use enormous wet cell batteries to do it. And all those are charged by the AC grid. So whether it's a head end for cable co or a head office for telco, they have hours and hours of backup DC power. It's highly reliable because, as I said before, you have to watch your TV show. You got to connect to your cell phone, right? You have to have internet. And even your homes are run through them now, so your security would go down. And the most important reason for reliability, I was told at QVC or working with Comcast, is they have to send out that cable bill to you so you can pay it each month. And so you think, well, these servers can't run for hours without cooling. So here's what they do. They also back up their cooling systems with the DC power by inverting it back to AC. Now, you remember I talked about the VFD in my house I can choose? For the last half dozen years, I've been putting VFD drives in these companies, right? So it's a bit of a tongue twister, so don't say it too fast, okay? But it comes in AC from utility, converts to DC for their distribution system, right? Then they use an inverter to go back to AC to feed the VFD, which then converts it to DC to run the drive. All those conversions have losses. Battery technology, I just installed. So this room seems rather large. About half the size of this would be a battery plant. Okay? They used to use wet cells for those as the primary choice. And now they're going with smaller, more compact, more reliable batteries that last longer. So maybe a quarter of this room will be used. So if you don't think there's been advances in batteries, it's happening. It's happening because the telcos and the cable cos are demanding it. So they're driving it too. All right? So Elon Musk, as you know, is building a 6 million square foot battery plant, right? So he can see the future there. So these 10,000 sites I talked about are already DC in their distribution system, so they're ready for the renewables, which we said solar and wind. And they're screaming for a UL-approved DC motor to drive those fans to cool their servers. So long-term power play here is DC. The spirit of this project is not to wait 5 to 10 years for it to be adopted. We are building this now. We're not waiting for subsidies that supported solar moving forward. We're not waiting for the subsidies for the Edison electric car. Oh, they call it a Tesla, which is really, well, I guess it sounds cooler, right? Germany just announced last week that they're spending $1.4 billion on electric cars to compete with Tesla. They're seeing it. And we can't wait for, oh, those cars were DC. I'm sorry, I was supposed to say that. Sorry. We can't wait for higher fuel prices to drive the market. We can't wait till it's warm in Norway to notice that there's global warming. The spirit of this project is not to wait 5 or 10 years. That's what they said at the last couple conferences I went to. 5 or 10 years for battery technology to catch up, to use these microgrids. The Alliance Center is a 40,000 square foot building. 94% of all office buildings in the United States are 50,000 square feet or smaller. And these batteries we're using to support our building are not taking up that much square footage compared to what they would have years ago. This project is the first building to do a power retrofit, a long line here, with a DC microgrid in a commercial building, and we're doing it in downtown Denver, in a historic building. I'm excited to be part of this game-changing project. Challenges, we've had many, and we've overcome them, but we have more. And to talk about some of those challenges that we're having, Jon Brooks here will talk about those, and he is the engineer that did the drawings and pulled together the design, so I can go ahead and building it now. Thank you, Jon.
As you can see, I'm not Dennis Deely, who's on your program. That's Denise. She couldn't make it today, so I'm filling in for her. So I am the designer. We led the electrical engineering design team that helped basically take all these ideas and make them into reality. The first thing I wanted to point out again is it is a retrofit project. It's actually a retrofit of a LEED certified building. So we already started with an energy efficient building. And we really didn't want to just come in and take everything out and start with with a clean slate. Our goal is to retrofit product for product, so like for like. We didn't want to change systems. We wanted to find similar DC products that match the AC product for a swap out of the installation. We also want to point out that we're maintaining the AC connection. We're not demolishing, we're not removing the AC grid tie. We're still utilizing the AC, so it's a hybrid system. This solution will allow us to transition over time. So it's not an all for one, day one, we're all DC. We'll transition slowly over time. So how do we do this? Well, the first thing that we have to do is find products that are available. So phase one, we mentioned a little bit about, Sandy mentioned phasing before. Phase one is what's available today as a DC product that we can swap out for our AC products. And that is the extent of phase one. In addition to that, we have a DC infrastructure that allows us to do future phases without damaging the infrastructure of the building, and allows us for easy tie-ins for future DC components. So phase two is we need to get more manufacturers on board. What products are not available today but could be available tomorrow or in the near future? So we're really pushing on those manufacturers to say, look, this is a product that the market needs, that we need, and we will implement. How can we get those? How can we push that envelope to get those into production? And then phase three is once phase two is completed, we will show how it can be done. Phase three is all of you, other building owners, adopting this idea and implementing it in their facilities. So we are creating a single efficient DC microgrid system within this building. It's all, as Sandy mentioned, self-contained. We're not trying to create more energy, send it back to the grid, resell it. It's all self-contained. We're trying to utilize all of the energy that's generated through the photovoltaic or native DC power supply sources. Within that grid, microgrid, we have photovoltaic, we have batteries, we have lighting, we have a rectifier. That's what changes the AC to DC. We have heating, ventilation, and air conditioning, and we have a microgrid management system. And the microgrid management system is a software package that helps tie everything together. That is what is the brains behind the entire operation. And believe it or not, there are really a limited amount of software developers and manufacturers that create this product. So it's really a key component of the design, yet was extremely hard to find. We also are utilizing modeling to predict the energy savings and energy consumption as this transition happens. But we're also utilizing meters to have, the proof is in the pudding. We're actually putting meters. We have installed already over 60 meters on the existing AC systems, which will be converted to DC. We've already installed those meters to track existing AC usage. And then when the DC system is installed, we're putting meters on those systems as well, and we can track the transition between the two types of loads. So we'll have pure factual data that we'll be sharing with everyone, as Sandy mentioned. So no one has done this before. This is really a groundbreaking project. I've done hundreds of buildings with renovations very similar to this, but all the renovations have been AC. They've not been DC. So really to be a part of something like this is pretty special. I think it's important to point out that if I, as an electrical engineer who has done countless projects over the years, if I can do this, if I can be a part of a team that's a building owner that just had a vision in mind, and other groups of consultants that stood up before, if we all can do it, you all can do it too. Thanks.
The team is absolutely terrific, and we know that there are going to be if we've been successful today, we have stimulated a whole lot of questions on your part. We are anxious for you to also know who the players are. On your table is a card that gives a little bio, so you can stay in touch with us and you can know who people are that are actually continuing to be involved in this. So I would like to open the floor to a series of questions at this point. Do we have microphone? Oh, there go microphone helpers. They should have Fitbits on.
Hi. Hello. Hello. So, my name's Katie Hoffner. Should I wait?
Okay.
My name's Katie Hoffner, and I'm from Fort Collins, Colorado, and my focus is on, Pareto battery and revolutionizing batteries. So hopefully we'll be part of a DC project soon. But I wanted to let you know, our utilities is building the first DC building. And I don't know if you know that, but want to encourage the collaboration because it's a very progressive municipality, and hope you're conversing with them.
Katie, thank you very much. Absolutely. We actually stay pretty closely aligned with CSU Powerhouse and with Fort Collins Utilities. One of the things that we are really anxious to do is to be able to be a pivotal point so that if somebody wants to know something about DC or about microgrids or about batteries, we are working very hard to aggregate all that information together because it is very disparate. And so thanks for sharing that one. And yes, we'd love to hear the other success stories and even the failures. I don't know about all the rest of you, but most of us examine our failures much more closely than we do our successes. And so I doubt very much that I am the only one that does that. So anxious to get that. Another, yeah,
Real quickly,
please.
to that, we are testing 4 different battery technologies within this project. So we're actually really trying to be a lab and a living lab experimental type scenario.
We also would love to have your experiment come to our building and use it as a field laboratory. And so I know you'll catch up with Katie before this is over, John. Somebody who's in batteries, we're anxious to hear from.
Yeah, I want to thank John for the vision and the willingness to do this, and also the whole team. My question really goes to the point of the light bulb that will have to be acquired without the plug-in. And how are you dealing with all of your tenants in the Alliance building and all of the issues concurrent with people coming in with computers and the equipment that's going to be needed to replace? I mean, does that exist? Are you asking manufacturers to retool? Are you creating a demand? And I guess the final question is, in the race to who's going to be the first DC building in Colorado, can we create some kind of a media campaign around that so we can raise the awareness?
I can certainly answer the transition component of your question. From a power outlet standpoint, we're actually adding a new DC outlet adjacent to the existing AC outlet. So we're maintaining the AC power outlets that you see on the wall for continuous operation so that they can transition over time. If you go to Dell's website, you can actually buy a DC connection for a laptop. What it is allows you to plug into your car. So your car charger, little circular car charger, that's DC. You can buy that for your laptop today. And we will have a little circular outlet that's a DC outlet. In addition to USB outlets, the newer Apple computers, they're being allowed to be charged by USB. It only has a single USB connection to some of the newer MacBooks. So we're allowing the transition to happen over time. From a lighting standpoint, Bern is coordinating the installation you guys are working early morning hours to make that transition as seamless as possible for the existing tenants. The light levels will be the same, the controls will be the same, really trying to minimize that impact.
One thing that's interesting, in terms of, say, for example, LED lights, And the example that Sandy's holding up at the base there is what converts the AC to DC. Now, imagine if you didn't have to have that light with the converter, how much less expensive it would be. So your CapEx is going to go down on some of these. And over your operating life, your OpEx is going to go down. People ask, what is the value of doing this? Well, we're doing a test because we want to do what others have not done and find out how much can be saved. Every conversion has a savings when you go from the DC in your photovoltaic panel to your AC, back to your DC in your products like this. Many products run more efficiently on DC, and people say, how much savings can there be? That's one of the goals and the outcomes for this project, is to determine that. Because we estimate that there's probably a 7 to 9% loss when you go from the DC to AC, and potentially a 7 to 9% loss when you go back again. And then all your operating time throughout, we're thinking that there might be in the range of a 30% savings, and that's what we're going to test.
A quick follow-up. Why, John, are you doing this?
Chip, I'm going to make final comments, but you started me, and I'll tell you why, and I'm going to thank you, and I'm going to thank AREDAY personally. I'm doing this because of a phrase that you said that is stuck in my head. The planet is on fire. We need fire people. We have to put that fire out. We are going to run the risk to find out how much savings can be achieved because it has to be done. And we can't wait, as the other panelists have spoken. We cannot wait. We have no luxury. We have no time. And I am very personally invested to financial risk because I believe in this. And if this is the last thing that I do in my life, it's to accelerate the adoption of a technology. We hear so much about the problems. People have to come up with solutions. You don't solve a problem without a solution. And that is why I am absolutely personally committed. The organization is committed. It's the direction we're turning because it has to be done. We don't have the luxury to wait. We have no luxury to wait.
Bob Goff, Intertribal Coup. I want to salute you for doing this. We've been looking at straw bale cluster houses on the reservation, microgrids, utilizing DC in that way, although I lament losing my foot warmer. This little device here has kept my feet warm in wintertime because of the heat loss in the transition from plugged into the wall AC to going to my computer DC. So I'll suffer through that. But I just want to let you know too that as we've been looking at this, there is an entire raft of RV and marine appliances and equipment already out there that work perfectly well beyond the computer and the plug-in telephone. So thank you much.
Response? Do you want to respond to the marine?
Well, that's exactly what we're trying to find out, is in a commercial setting, in a commercial building, to scale it from what would be already existing in the marine and the RV environment, to make that available. I mean, there's some off-grid utilization, particularly in residential use, but the commercial use, as Bern mentioned, that 94% of the buildings in the United States are less than 50,000 square feet. We're 40,000 square feet. So we look at ourselves as a pretty good model and an opportunity to demonstrate things. And is it going to be a challenge? Yes. Is it multi-phase? Yes. Is there a third phase in which we have to wait for the manufacturers to catch up to us? Yes. And one of the risks that someone pointed out to me, leadership has to have people who work with you. Because if you get too far out in front of the pack, you're not a leader, you're alone.
The other thing that we're doing is we've taken a look at UL, and John, you want to just run through the field approval process that we have uncovered around UL?
Because we haven't, especially in the retrofit market, we haven't found all that many readily available products, including through the marine industry, which in a new installation, you can find a lot of available products. So what we've spoken with UL, and they actually will come out to the facility. approve or review and then approve the installation on site, say for a light fixture retrofit. Because you can talk to light fixture manufacturers and they'll say, we won't approve it per UL, but yeah, this is a DC product. If you just put this wire with this connection, it'll work, but we're not going to UL list it. However, UL will come out and they will approve it. So there are ways, creatively thinking, that you can get UL approval and you can get jurisdictional approval.
And if we can standardize on the voltages that we're using, then we'll have less conversions and transformations of the DC. And the early adapters, hopefully, people that we were using early on, can be the leaders, and we can use the voltages they're set at. I have a bucket of adapters at home, AC adapters, that provide a 1.5 volt to 15 volts for different devices I have. There's no real standard there. If we can do that with DC, we'll save a lot of power.
Thank you, Bern.
One other point is getting manufacturers to honor warranties. Right now, you can take your TV apart, you can bypass your converter, and in so doing, you're going to void your warranty. So yes, Chip, it's a long-term play.
One of the decisions we made early on was that, first of all, for those of you who just haven't been in the Alliance Center recently, just over 2 years ago, we finished a multi-million-dollar transformation of this building. Some of these light fixtures are hardly warm that we're talking about retrofitting. And so the warranty question is one that we have addressed. And we have said we are willing in some cases to risk the warranty if, for example, there were a way to get to the air conditioning, the HVAC system, because the HVAC system is the single biggest user in our facility. We know that. We have no fossil fuel burning. So we know the HVAC is the biggest single consumer of our electricity. We are looking for a way, we'd love to find a bench test to do that, but failing that, I am guessing that VFD motor is going to have a couple new wires attached to it in the not very distant future, because phase 1 is designed to be functional by the end of the 4th quarter. By next January, my fingers are going to get really itchy around the air conditioning and heating system that we have. And so, yes, we are willing to accept some calculated risks on the warranty side.
And Denise Deal, who's not here today, she's our mechanical engineer on the project and researching these things in the future. I think she said that, to us, that she's found products in catalogs that exist, and when you go to order them, they say they don't make them. So
It's close.
Sam, you had a question?
Yeah, my name's Tim Wirth, and I want to thank you all very much for a good presentation. I've long been an admirer of Jon's and the Alliance Center. Let me pick up on your final comment, Jon, about the urgency that we face. I want to ask you to comment on scale. How do you translate that sense of urgency to the scale that's going to be necessary? In other words, another way, where are the utilities in this? Are utilities working on this? Are they engaging this? Is this happening elsewhere in the country? I don't think you can get from where we are now to where we want to be unless we use these enormous systems that are already built in all over the country. So if you could address that, I think that would be really helpful. Thank you very much.
Part of what we're doing is modeling. Not just modeling on a technological side, but modeling as a direction people can take. I describe it as bottom up in terms of commercial buildings, right? This is what we can try to do to get the market to move from that scale. And from the top down in the utilities, now that the rapid advances of storage and battery technology. So when people come to the Alliance Center and we give them tours and we talk about it, and same as this forum and other fora, that people are now calling us to ask us to make presentations where we were trying to find a way to reach out to be invited to places. We want to do the modeling to show what you can do from a bottom up and what you can do from a top down. And that's it. Now, how much resistance might there be? There's certainly going to be reliability is huge, but the developments in batteries now, we talked about size, we talked about power, but they're a drop in cost, that they're now being adopted for spinning reserve, for example, when a coal plant that has 12 boilers, and 6 are in operation. They keep 2 that are spinning, but they don't produce any electricity, so that they can, like a clutch. You know, you can engage it when you need the electricity, but now they're starting to apply batteries for that sort of application to be able to displace spinning reserve. I mean, our long-term goal is to get away from base load from fossil fuels and be able to do base load from batteries and from renewables. And the example that we're creating, and when we talk about being LEED certified, the Alliance is the first building, the Alliance Center is the first building in Colorado and the 5th in the world to get LEED dynamic plaque, which is real time. Now, we have only achieved gold. And the reason we achieved gold is the power supply coming into the building is so dirty. 56% of the energy generation in Colorado is from coal. But by doing this project, we hope that, again, through the publicity and the marketing and the awareness that can be created, we want to use the opportunity to get to platinum with this project is one more platform on which we can make the announcement for other people to adopt it. And one other point that is really intriguing, there's a lot of the world that doesn't have any access to electricity, right? They don't have to go through the path that we've taken through alternating current. They can go directly to direct current. They can leapfrog us. Why should we be leapfrogged? When Huan Ming put a challenge out about working together, and that's what we're doing here to get this to proliferate, we're asking all of you to join with us, because only by that means, Tim, are we going to get it out. The platform that you represent, it's enormous. We need to be able to be a proof of concept where you can look at us, where we can share information, where we can partner with you, you can partner with us. We've got a bowl, we've got a display table in the next room. There's a bowl. Leave your cards there. Ask us for our cards. Go to the website. And there's also the DC leading group in the United States is called the Emerge Alliance. And fortunately, we have one of the 2 leaders of the Emerge Alliance who is with our team here, and Paul Savage. And this is another mechanism by which it's going out. This is not kind of a solo effort. When I said leadership, get out far to be a leader, but not so far that you're alone. The Emerge Alliance actually has been out there way ahead of us, breaking trails. So we're following along with them. There are a great number of opportunities for you all to get engaged. And I really hope that you will, and I hope that we collectively will rise to Huan Ming's challenge. That something we can do and something we might be able to do with Huan Ming, with China. We shouldn't be left behind. We should be having good development here as we did with solar panels and they went to China. We have this technology and this opportunity. And I think we're getting close to being out of time. So if I may, I'm going to just make a couple comments. What we need is we all need to get educated. We need to understand the opportunity. We need to overcome the barriers. We need to accelerate adoption in buildings. We need to accelerate applications of energy storage. We need to move the markets. We need to increase demand. We need to spur development and availability of new DC equipment. We need to spur UL to minimize cost and length of time to get approval. We need to standardize voltage. We need to overcome building codes and regulatory barriers. A couple years ago, I had the privilege to hear, maybe some of you else also did, a fellow named Robert Swan. And he made a quote that will forever stick with me. The greatest threat to our planet is the belief that someone else will save it. You have an opportunity tomorrow to go for a tour of the Innovation Center in Basalt. Rocky Mountain Institute's absolutely leading. To Friday, you will have the chance. And I encourage you to do that. The Rocky Mountain Institute was 2 or 3 years ahead of us, and they chose not to do DC yet, but they've made their building DC ready. So there are these opportunities that are pregnant, if you will. And as David Orr said, we need to go to scale, we need to go to speed with a fierce urgency, and by us getting on board and developing the market demand for these, we will make these products affordable. And we will include one of the returns on investment to be profitability, but risk, security. When they're doing these DC data centers, I was really intrigued to learn that the biggest challenge they have is the risk of them going down. Because when they are not operating, not functioning, they lose so much money. And it's a parallel to what happens to the US, what happens to our importing of energy, it happens to our military security. These are all parallels. What we're doing has multiple returns on investment. It's not just financial. We need to think in a much bigger scale, much more urgent scale, to rise to the point that Tim raises. We all have to do this. We have to take a corner of the blanket, and we have to throw this solution higher in the air with a fast snap. So thank you all for listening.